In today's class, we are going to see how to create or write the or building each test bench components. Okay. So this is the UVM simple UVM test bench architecture. Okay. So here test bench is nothing but top module name. So within that we have to instantiate our DUT and actual physical interface. Then using run test, we are instantiating the particular test. Within run test, within that bracket, what is the test name you are giving, that test will going to execute. So within the test, we are what we have to do. One thing is we have to build the environment. Okay. So we have to build the environment, and another thing we have to tell which sequence has to pass to the which sequence. In this case, we have only one sequencer. So these are the sequences available separately. Okay. So in test, we have to mention which sequence has to pass to the sequencer. That map or start method is there. Okay, using that, we have to start sequence dot sequencer. So automatically, these sequences will pass to the sequencers. So when we build a test, okay, automatically environment will be built. Inside the environment, agent will be there. Agent will be automatically built. Okay, inside the agent, we have these components to be instantiated. So these will be built automatically or created. So when inside the test, we are instantiating the actual running process. Sequences as like a generator. So it pass the sequence item to the sequencer. So the sequencer, with the help of TLM port, transfer the transaction to the driver. So driver, it will convert the transaction into a bin level, and through the interface pass to the DUT. So monitor, we are instantiating the interface so that whatever the transaction happens between the driver to DUT, that also captured by the monitor, and also the outputs we are getting in the monitor. And again, the pin level is converted into a transaction level, and it is sent to the scoreboard. Here we are checking the input and outputs. So configuration, it is a separate class is available. So in the test, we can configure the configuration class, and we can set in the config DB. And here in agent or everywhere, wherever we need, we can get the config DB by using get method. Can implement. So now we will see each and every component, how to develop the components. So UVM sequence, getting nice. Please mute it. Okay. So this architecture is a UVM sequence-based stimulus generation architecture. So this part. Okay. Here sequence is nothing but inside this sequence we are instantiating the sequence item. Okay. So based on the with the help of this sequence item, we are generating the sequences. Okay. For example, I want to perform read write. Okay, the sequences as like generator. Okay, so with the help of sequence item, I can able to generate the sequences. Then in test, I will mention this sequence should pass to the sequencer. So it will transfer the sequence item to the sequencer. So sequencer and driver, there will be a TLM port, there will be a handshaking mechanism happens between these two. So that I will explain in detail later. So through the TLM port, this pass is given to the driver, and it is converted into pin level and sent to you. So first we will see what's a driver, okay, and how to build the driver. So driver, it drives the data item to the DUT following the interface protocol. So it just not simply convert this transaction to pin level and just not sending. Based on the protocol, if I follow APP protocol or ASP protocol, okay, we should design according to the protocol. The pins or signals should be sent to the DUT. There will be a condition, right, when to send. Okay, so appropriate condition we should design in the driver, and it gets data item from the sequencer for execution. So there is a method get next item. Okay, so with the help of that we are getting or pulling the data from the sequencer. Then the UVM class library plus UVM driver, it is a base class available by default. So it is injected from UVM component. So directly we can use this UVM driver to develop our own driver. So here inside the driver we have a run method. So actually the run phase, okay, there we are implementing our actual logic. Okay, that the transaction is converted into pin inside the run task. So with the help of the alarm ports, we can communicate with the sequencer. How to create a driver? So driver is extends from UVM driver base class. So inside that, if you want, you can implement a print, copy, compare. This is already available. You can replace those things. If you want, you can print the data in the driver. Okay. If you want, you can do some copy over there. Then here inside the driver, we need to actually here we are converting the transaction into pin level. Through the interface, we are sending the signal. Okay, so I need interface in my driver. So I want to get my interface. So I need to declare a virtual interface in driver, and using a get method, I can able to get the actual physical handle of the interface. So here run method, we are getting the transaction from the sequencer by using get next item that I will explain in the code. Okay, is it visible?
Yes, sir.
Yes, sir.
So can you zoom it, sir?
Are you watching in mobile?
Yes, sir.
Here the name simple driver I am creating. Okay, so class simple driver extends UVM driver, so it is available. So by this I am inheriting my simple driver. So while inheriting, you should parameterize with this sequence item type. So I'm going to dealing with the sequence item of simple item. The name of the sequence item is simple item. So I should parameterize this UVM driver as simple item. So inside the driver, here I am instantiating the virtual interface handle. Then this is used to register this simple driver to the factory, UVM factory. Okay, with the help of UVM component utils, I register this driver to the factory. So this is the new constructor for this simple driver. So here I instantiate the simple item as S item, okay, because I'm going to receive the S item from sequencer. Okay. So the driver should know what is S item. So I instantiated here. So I declare this S item as a simple item. Then in build phase, I want to get the interface handle. Okay. So VAF is the interface handle I declared here. Okay, this one. So for this, I need to get the actual interface using get method. So inside build phase, I am getting UVM config DB. It is a type of virtual interface, virtual DUIF. Using get method, I am getting this double quote VIF, this VIF. This VIF is already registered, that is stored in the config DB, that variable name. Here this VIF is the name I used here. Okay. So I will get the actual interface handle. If I am not get, I will get this factor lab. Then in run phase, so here inside the run phase, so this sequence item port is nothing but the TLM port defaultly available in the driver. Okay. So I in this code I didn't declare or instantiate this TLM port. It is available by default in UVM driver. So I just use it. Sequence item port dot. So get next item is the method available inside the UVM driver. So this method is implemented in the sequencer. So with the help of this, I can able to get this S item. S item is nothing but sequence item. So after receiving this S item, I am writing a separate task. This is a task I am writing here below. Write drive item. So I am passing S item. Here I am getting S item as item. It is of a simple item type. Here you can implement the logic that item dot data, okay, that you should assign to VIF dot data. So in that way you can do your actual conversion, transaction to pin level conversion. You can do it here. Then once this process completes, you have to call this method sequence item port. So this is the TLM port available here. This inside that I have a item done. This is a method available. Okay, so it is used to tell that this process completes. Okay. It will, this method item inside we go through the item done method. So inside that it has the response. Okay. So automatically when you call this method, it tells that for this request, this is a select request. I am getting this sequence item, and so it completes. I am sending the response. Like that, it is created. So that's all about driver. So next, sequencer. So sequencer is a component that passes stimulus data from the generator to driver. So nothing but the sequence. So it gets the sequences, okay, and it sends to the driver. That is the sequence. That is the use of sequencer. Another use is when multiple sequences can be tried to send the sequence item to driver. So this sequencer is going to act as an arbitration. It acts as an arbiter between them. It will decide. So there are different arbitration mechanisms available in sequencer. So that we will discuss later. So based on the arbitration mechanism, so it will decide which sequence you have to pass to the driver. Okay. So when multiple sequences trying to send the data to the driver, so this sequencer is going to act as arbitration and it will decide which sequence you have to pass to the driver. Okay. Then it is base class is UVM sequencer. From that you can able to derive our sequencer. So then new sequencer. So these methods I told, right, get next item and item done. Okay, like that we have a few more methods. All the methods are functionality are inbuilt available, implemented in the sequencer. Then while you inheriting, you have to pass the two things. You have to parameterize this sequencer with simple item and simple response. Okay. So actually, this sequencer. So this is the top class we have UVM void. From UVM void, we are inheriting UVM object. From UVM object, inherited UVM report object. So from report object, we are getting UVM component. So from UVM component, we are getting UVM sequencer base. So after that, by UVM sequencer base, we are getting this UVM sequencer param base. So finally, this UVM sequencer is inherited from this UVM sequencer param base. So in UVM sequencer, you go through the class. So this is the actual UVM sequencer base. From this, we are extending this UVM sequencer. Okay. Here, RUQ. So that type you have to mention. RUQ is a request. In driver, if you see, we have to parameterize with the sequence item type. Okay. So if I use sequence item as a type, so I should mention sequence item type here. Okay. So here this request is assigned to response in UVM sequencer. Okay. So if you pass the sequence item type here for request, automatically it will assign for response. So response also it is a type of the sequence item. Okay. So UVM sequencer also dealing with the sequence item. So you should parameterize UVM sequencer the sequence item. Okay, this code class simple sequencer extends from UVM sequencer. So from this we are inheriting our simple sequencer. So it should be parameterized with simple item. Simple item is nothing but simple item is nothing but sequence item. Okay. So here you can also mention the request type and also response type. Otherwise, if you mention only request type, that is enough. Okay. Because inside the implementation of UVM sequencer, this type is automatically assigned for the response type. Then inside the sequencer, every methods, that means get next item, then those methods are available by default, and also the TLM ports also available by default. So you don't need to explicitly define again, okay, inside my sequence. It is not required. Okay. So UVM sequencer contain all those things. We just extend this UVM sequencer and we can write our simple sequencer. Okay. Then this simple sequencer should be registered to the factory. Then for the simple sequencer, you have to write a constructor, okay, new constructor. That's it. That is enough for a sequencer. Okay. Then sequencer driver connection. So I already told that these ports, sequence item export and sequence item port, defaultly available. Okay. Sequence item port is available in driver and sequence item export available in sequencer. Okay. So we have to just make the connection between them in the top level hierarchy. So which is the top level hierarchy of sequencer and driver? It is agent. Okay. So inside the agent, we have to make the connection between them. So already told this get next item we are using in the driver. Okay. So inside the driver run phase, we are using get next item. So this is a method implemented in the export part where we are using inside the sequencer. It is already defaultly available in UVM sequencer. So that by calling that API, okay, we are able to get the sequence item. So in agent connect phase, we have to make the connection between the driver and the sequencer. So how to make? By using connect method. Okay. So I told already the export should be always inside the bracket. So driver has the sequence item port dot connect in the bracket sequencer dot sequence item export. This is the how to make the connection between port and export. Then you will see what's a monitor and how to create a monitor. So it extracts signal level information and translate to object events or high level information. So it is from the interface, it abstract the signal pin level and it is converted into transaction, and this transaction is passed to the another test bench components like scoreboard and coverage, okay, with the help of TLM ports. So this is the way it is connected. So monitor, here we have to instantiate the virtual interface, and using get method we have to get the actual interface handle so that we can able to get the pin level signals in monitor. So here what is the actual operation of monitor is it converts the pin level information into driver. In monitor we have to declare analysis port. So why I am using analysis port here? Because the analysis port we can able to send the transaction to many, one to many we can able to send. Okay. So usually we use a write method. Here I am using write method as a API. Okay. In monitor, first thing you have to declare analysis port, and using the help of analysis port, I can by using write method I can say able to write the data. So that means transaction. Okay. So this write method will be implemented inside the export where I am using coverage collector or a scoreboard. Okay. So this write method will be implemented over there here. And in the top level hierarchy, so where I am using the monitor, that will be available inside the agent. Okay. This scoreboard will and coverage will be available inside the environment. So in environment, I have to make the connection between the monitor and the scoreboard. That you will see the environment part. Then how to create a monitor. So here UVM monitor is a base class available. By extending from this UVM monitor, we can create our own monitor. Then implement logic to monitor signal level information. So I need to declare a virtual interface inside the monitor to capture this pin level signals. Okay. Then we have to translate the pin level information into transaction level. Then implement the analysis port to send the transaction to monitor to the coverage or scoreboard. Okay. I need analysis port, so that you have to implement inside the monitor. See the code of monitor. This is the output OP monitor, that's output monitor. I am extends from UVM monitor. So here I registered my output monitor to a factory, and I declare a virtual interface handle, so that only I can able to get the signals, the actual the DUT output input I can able to get it here. So this is just a virtual interface handle. So I need to get the actual handle of physical interface. So in function void build phase, by using this get method, UVM-Part DB, it is a type of virtual interface. Okay. Get parent. This is just a double quote. My interface, the actual interface is there. So that one I am getting for this period. Then I need analysis port to transfer the transaction to scoreboard or checker or coverage. So I need to declare an analysis port. Okay. So this analysis port should be parameterized. Okay. Here I am dealing with the packet. Packet is nothing but my transactional sequence item. Okay. So I insert such a PKT. So this is new constructor for this output monitor. And the build phase, I have to create a packet, okay, by using create method, and analysis code. I am creating an object for this analysis code. Then in run phase, the actual operation. Actual operation, what we have to do here is how to convert the pin level into transaction level. So here, this is the condition you have to check. Okay. So when you have to sample the data, always we are not going to do that, right? So like that we have to, when reset is 0, that means here this is active low. Assume that DUT is active low. So when reset is 0, it will be active. So here I am checking for read. Okay. So read enable, read select should be 1, read enable should be 1. So that time I am taking the interface signal and I am assigning to the PK. The same way for write, I check the condition, and while writing I am taking the data and the control signal and I send to the put into the packet, that is running the transaction. And here by calling the write method, I can able to send this PKT to a coverage or a score. So it's an output monitor. Then agent. So inside the agent, you have a sequencer, driver, and monitor. So the agent collection of group of UVM components focused on specific pin level information. So if, DUT supports multiple protocols. So there are some pins dealing with APP, some pins dealing with ASP, some pins dealing with AXN. So for each pins, we need a different agent. Uh, for sending the data through ASP protocol, so I need a separate agent dealing with this protocol. Also, we have the configuration components. So agent, inside the agent, you can able to configure whether it's an active agent or passive agent. So that we need a configuration component inside the agent. Okay, then agent we can reuse. In DUT, we have multiple set of modules dealing with the APP protocol. I can reuse this agent multiple times, or where I am using the APP, I can use the APP agent. Okay. So one time I can design, and wherever I need, I can reuse those things. So this point I already told. So active agent means it is have monitor, driver, and sequencer. Passive agent it can contain only monitor. So it is agent. So inside the agent we have driver, sequencer, monitor, and also configuration class. Okay, we need to get the config DB. Okay, if any configuration settings we made in test, that we can get it here. According to that, we can make the enabling or disabling that we can make the help of configurations. Then, so in this diagram, you see this DUT is supported for GPIO port and APP port and SPI port. Okay. So I need 3 types of agent. One is GPIO agent. So inside that we have monitor, driver, sequencer, then APP agent and SPI agent. So this is a separate environment we have. Okay. So this is a separate environment we have. So inside the environment we have the configuration class, okay, that defines. You see here I am inside this GPI environment I have a ABB agent. So here I am not going to use that. So in configuration class I can disable that one. So that you have to define a configuration class. Using the help of configuration class, you can able to control the performance, control the actual content of the environment. Whether we have to use those things, or if we don't want to use something, that you can disable with the help of this configuration class. So if you have multiple environment, that should be comes under a top environment. So in top environment also we have a configuration class to configure this GPI environment, to configure this SPM. So you will see example of simple agent. So it's an agent, it is extends from UVM agent. Simple agent is extends from UVM agent, and it is here is active. It's a variable. It's a type of UVM active passive venue. The UVM active passive venue is a data type available in UVM. It has UVM active, UVM passive, those things. Okay. So here I just declare this active as this data type. Okay. So inside the agent, we have a sequencer, driver, and monitor. I instantiated all those things, and in build phase, I need to check is active or passive. Okay. Just what I said I don't know, so that I have to check it here. Okay. So by using get method, I can able to get that is active. In case in my test, if I set is active as active, UVM active, so that I will get it here. This line. Okay. So after I get it, I am checking is active equal to UVM active or not. If UVM active is when in the test, if I give is active as UVM active, okay, so automatically this will take effect, because if this if condition is getting true, so sequencer and driver will be created. So monitor is defaultly created. So when UVM is active is UVM active, all the components will be created. If I set as a UVM passive, okay, so it won't be created. So in this agent, I have only monitor part. So in connect phase, so it is agent, right? So you should connect the TLM ports of sequencer and driver. A driver dot sequence item port dot connect sequencer dot sequence item export. So this is simple agent code. Okay, on top of agent, we have UVM environment. So environment is a top level container. Okay. All agents are instantiated and configured in the environment class. So most verifications used happen in the environment level. Okay. So in environment we can decide, we can configure the agents, and if if we want to use multiple, if you want to use an agent for multiple times in the DUT, so you can configure it here in top level environment. And it has the configuration object that can control number of agent, and the environment config set, agent config. So everything setting configuration of the agent will be available in the environment. Then we have a component like scoreboard and coverage monitor, and the connection between the monitor and scoreboard, that also we have to make in the environment. Now I will show you environment example. So this is a simple environment. So ENV is extends from UVM-ENV. So here I register that to factory. So inside the environment, you see there is an agent and scoreboard. You remember the diagram, okay, architecture diagram, you can get it. Then inside this, I'm creating a new for this environment. Then inside the build phase, I am creating agent and scoreboard, okay, by using create method. And then I have to make the connection between monitor, okay, where is the monitor available inside the agent. A dot m is the handle of monitor, and this key port represent the name I gave for port, okay, sequence item port. So not the sequence item port, it is the analysis port, okay. And dot connect scoreboard. Inside the scoreboard class, I implemented a analysis export. The name of the analysis export is report. Okay. So this is the way you have to make the connection between scoreboard and monitor. So this is a simple environment. So if you have multiple agents inside the environment or multiple environments, then you have to do the configuration. You have to access the configuration class, and you have to make your settings, and you have to set that to the config DB. And the agent, you can able to get the config DB, and based on that you can decide or design your agent. Then UVM test is top of environment. So test is the top level class that instantiates ENV environment and configures the Testbench and instantiates constructs. So individual tests derived from UVM test. Each test case instantiates UVM environment and configures them. So here test is going to control the whole architecture. So each test, when you run a particular test, each time the environment will be created and it will get configured according to the test, and we are passing the sequence to the sequencer, and we are doing the test operation. Then Testbench activated the call run test. Okay, this run test you have to mention inside the top module. So within this bracket you have to mention which test I am going to run. So actually this is start at the build phase. This run test will start at the build phase. Actually the connection should be made. Okay. Then you have to start the run test. You see separate code of that. A class base test, this extends from UVM test, and it should be registered to the factory. So inside the test, I am instantiating environment and sequence. So why I am instantiating the sequence means here I am going to map or start in run phase, in actual run phase. Inside the run phase, actual process is going to start. So here I am going to I am telling that sequence. Okay. For example, if it is a write sequence dot start, I have to tell this where this sequence should go. Okay. It's actually mapped with this sequencer. Where the sequencer is available inside the environment, we have agent. The agent containing the sequencer. So this is the way you have to tell you have to start the test. Okay, the actual tomorrow we will discuss about the sequences. Okay, how we are generating the sequence. Okay. So these sequences are sending to this sequencer by using start method. Okay, inside the run phase of test. Okay. So the remaining are set inside the build phase. We have to build the environment. Okay, and here I am setting. I want to use the agent for this test as a active agent. So I need to set this is active as a UVM active. So here I am setting this active equal to UVM active, UVM active. So this one I am setting to a config DB here. So in agent I can able to get that is active as a UVM active, and I will configure that. So this is the simple test. Okay. So if we want to run more number of tests, I can. If you define this as a base test, you can extend this base test. Okay, and you can write your further tests. Okay. That's for today. So tomorrow we will see how to write the sequence. Okay. So actually, one more thing you have to see sequence item. So sequence item, you see it again. Okay, sequence item you already know, right? Sequence item consists of the properties which we are going to use as input and output for the DUT, and the methods which is helpful to uh, manipulate with that properties. Okay. So with the help of sequence item, we are going to generate the sequences, okay, inside the body method. Okay, that how we can do those things we will see tomorrow.